Hello, this video is about reviewing some of the algebra topics that will be useful in this upcoming unit. So in this video we are going to review simplifying with radicals, solving using square roots, and solving by factoring. So first, when we are solving with rational expressions, we're simplifying using radicals. So sometimes when we take a square root, if the number under the square root is a perfect square, we know right away that the square root of 121 is 11. Other times we aren't as lucky and it's not going to be a perfect square. And if I put in my calculator, I would get a decimal. We don't want a decimal answer. So what we're going to do instead is we're going to break down the number underneath the square root into prime factors. So we need to find numbers that multiply to the number under the radical. So two numbers that multiply to 150 are 15 and 10. Now you can divide it in multiple ways. It doesn't matter which factors you pick as long as they multiply to the number. Then we can break down 15 into 5 and 3, and we can break 10 into 5 and 2. Now, all of those numbers left are going to be prime factors. So once we have our prime factors, we want to look and see, do we have any pairs? So in this case, we have a pair of 5s. Any number that is a pair, one of those numbers from the pair is going to go outside the radical. Anything that was a prime factor that does not have a pair is going to go under the radical. So in this case, we have the 3 and the 2. If there are multiple numbers inside or outside of the radical, we are going to multiply them together. So underneath the radical, we have 3 times 2, which simplifies to 5 root 6. In number 3, I need to break down the square root of 128 first, and then I'll deal with the 1/4. So 128 breaks down into 8 and 16. 8 breaks into 4 and 2. 4 breaks to 2 and 2. 16 breaks to 4 and 4. And each of those 4s break into a pair of 2s. So when I'm looking at my pairs, I have a pair of 2s, a pair of 2s, and a pair of 2s. There was already a number out front, so that coefficient of 1/4 is going to multiply with our pairs. So we would have 1/4 times 2 times 2 times 2. There's still a 2 left over, so under the radical is another 2. Now, when I multiply 1/4 times 2 times 2 times 2, I end up with 2 root 2. Number 4, we have negative square root of 16,200. So two numbers that break down in from that is 100 and 162. 100 breaks down to 25 and 4. 25 breaks down to 5 and 5. 4 breaks to 2 and 2. 162 breaks to 2 and 81. 81 breaks down to 9 and 9, and each of those 9s break into a group of 3. So in this case, we still have that coefficient of the negative, which remember is a -1. So we have -1 times, we have a pair of 5s, a pair of 2s, and 2 pairs of 3s. Left over is this 2, so that's going to stay under the radical, so this simplifies to -90 root 2. Now when we have 2 radicals that are multiplied together, the numbers that are outside the radicals are going to multiply together, and the numbers that are inside the radicals are going to multiply together. So this gets us 15 root 294. Now I need to break down 294. If I'm not sure what numbers multiply to 294, I can go back to the factors that I originally multiplied. So I can do 14 and 21. Two numbers that multiply to 14 are 2 and 7. Two numbers that multiply to 21 are 7 and 3. So we have a pair of 7s. That's going to multiply outside with the 15. And under the radical, we have a 2 and a 3 left over. So that is going to simplify to 105 root 6. Now, when we have a radical in the denominator of a fraction, sometimes they can divide together. So because both of these numbers, 80 and 5, are both under the square root, we can just do 80 divided by 5, and we get the square root of 16, which we know is 4. In number 7, when we reduce, this reduces to the square root of 27, Now 27 is not a perfect square, so we can do our prime factoring. So two numbers that multiply 27 are 9 and 3. And 9 breaks to 3 and 3. So we have a pair of 3s and a 3 left over. Now, in 8, we're not as lucky. We can't divide. So what we're going to have to do is we're going to have to rationalize the denominator. So in order to rationalize the denominator, you want to multiply the numerator and the denominator, which are the top and bottom of the fraction, by whatever radical is in the denominator. So in this case, we have root 10 and root 10. So 5 times root 10 stays as 5 root 10. Root 10 times root 10. Anytime you multiply the root with the same number underneath, the roots cancel out, and that leaves us with 10. Now the number 5 and 10 can reduce together. They're both divisible by 5, so we would have root 10 over 2. Number 8. We have a root 2 on the bottom, so we're going to multiply by root 2 over root 2. So that gets us 18 root 6 over 2. 18 and 2 reduce together to get us 9 root 6. Now, adding and subtracting radicals. Adding and subtracting radicals is like combining like terms. The number under the radical needs to be the same. So right now, nothing combines together, but we can break down two of these radicals. So we can break down 12. We have 4 and 3, 2 as our pair. So we have 6 root 5 minus 9 times 2 root 3. 45 breaks down to 5 and 9. 9 breaks to 3 and 3. So we have plus 3 root 5 and plus 4 root 3. So if I simplify a little bit more, I have 6 root 5 minus 18 root 3 plus 3 root 5 plus 4 root 3. Numbers that have the same thing under the radical, so 6 root 5 and 3 root 5 can combine together by adding the coefficients, so 6 plus 3 is 9 root 5. And then we have negative 18 root 3 plus 4 root 3, which gets us minus 14 root 3. Number 10, we have to simplify all of our radicals first. So two numbers that multiply to 54 are 9 and 6. Two numbers that multiply to 9 are 3 and 3. 6 is 3 and 2. So we have a pair of 3s and a 3 times 2 left over for 150. Two numbers that multiply to 150 are 15 and 10. 15 breaks to 3 and 5. 10 breaks to 5 and 2. So we have a pair of 5s and a 3 and a 2 left over. And then in 24, 6 times 4, 6 breaks to 3 and 2. 4 breaks to 2 and 2. So we have a pair of 2s left over. That's going to go out front. So we have negative 2 root 3 times 2. So when I multiply, I get 3 root 6 plus 5 root 6 minus 2 root 6. Now they're all root 6s, so we can combine them together. 3 plus 5 is 8, minus 2 will get us 6 root 6. Now let's move on to a different topic where we are solving for x. So in these problems, we have a squared term and then we have constants. So we need to solve for x. So when you take the square root of both sides, which is the inverse to squaring, we need to include a plus or minus sign with our roots. Now we know the square root of 49 is 7, so we would have x equals plus or minus 7. Number 12, before I can take the square root, I have to subtract 31 from both sides. So I get x squared equals 99. Then we have to take the square root of both sides. So we get x equals plus or minus the square root of 99. 99 breaks down into 11 and 9. 9 breaks to 3 and 3. So we have a pair of 3s that come out front. So x equals plus or minus 3 root 11. 13. When we are squaring with a square root, what's going to happen here is it's really 3 root 2 times 3 root 2. So what's going to happen is the coefficients are going to multiply out front. So 3 times 3 is 9. The square root of root 2 times root 2 gets us the square root of 4, which is 2. So this would become 18. You can also do that on your calculator, but make sure you use parentheses. So we would have parenthesis 3 root 2, close parenthesis, and then square it. You need to make sure that the squared is outside the parenthesis, otherwise it's only going to apply to the root. So that would be 18. Now, once we're here, we're going to subtract 18 from both sides. We get x squared equals 62. Take the square root of both sides. We get x equals plus or minus square root of 62. Now, 62 can't break down at all because it would go to the factors of 2 and 31, and those don't have any pairs, so we're left at the square root of 62. Number 14, in order to solve for x, the first thing we're going to do is we're going to subtract 10 from both sides. So negative 5x squared equals negative 140. We're going to divide by negative 5, so we get x squared equals 28. So we have x equals plus or minus the square root of 28. 28 breaks down to 4 and 7. 4 breaks to 2 and 2. So we'd have x equals plus or minus 2 root 7. 15, we're going to square each of those terms. So 4 root 2 squared is 32, plus 2 root 17 squared is 68, equals x squared. So when we add those together, that gets us 100 equals x squared. We take the square root, we have plus or minus the square root of 100. And 100 is a perfect square, so we would have plus or minus 10 is equal to x. Now, in the last few problems, we have a squared term and a term with that same variable. So these are going to be factoring problems. So in 16, remember we need them to equal 0. Then, once we have it, we're going to do x squared, the x term, and the number. So in this case, we want to figure out what numbers multiply to 12 and add to 7. So we're thinking of factors. Two factors that multiply to 12 are 6 and 2, but those don't add to 7. Two other factors of 12 are 3 and 4, and those add to 7. So we're going to have two sets of parentheses with an x in each, and then we'd have plus 3 and plus 4. Then to solve for x, what's going to happen is each of these is going to be set equal to 0. So we would have x equal to negative 3 and x equal to negative 4. Now, you don't have to show this step. You can just show that x is negative 3 or negative 4. This is just a reminder of why that happens. Number 17, in order to factor, we need to get the equation equal to 0. So we would have x squared minus 5x minus 36 equals 0. The reason I want to move the 5x is because I want the x squared term to be positive. So now I need to figure out two numbers that multiply to negative 36 and add to negative 5. So if I'm multiplying to a negative number, I need one of each sign. So I would have negative 9 and positive 4. So we have x minus 9 times x plus 4 equals 0. So when I switch my signs, I would get x is 9 and x is negative 4. Number 18, when we get everything to the x squared side, we have 3x squared minus 15x plus 18 equals 0. Now, first we want to see if we can take out a GCF. So in this case, we can divide everything by 3, which leaves us with x squared minus 5x plus 6 equals 0. And we have a 3 out front. You can either divide by 3 or you can leave the 3 out front as your GCF. We're going to factor this part then. So we need two numbers that multiply to positive 6 and add to negative 5. So we have x minus 2 and x minus 3 equals 0. Now the 3 out front doesn't have an x, so we're just going to ignore that part when we're solving for x, and we just get x is 2 from the first parenthesis and x is 3 from the second parenthesis. Now, 19, we don't get as lucky because there's not a GCF between them. So what's going to happen here is we're going to use splitting the middle, which is also known as the Batman method. So what's going to happen is we want to multiply the last and the first term together, which gets us negative 24x squared. And then we're going to bring those two terms down. So we still have 2x squared. We still have minus 12 equals 0. So now we need two terms that multiply to negative 24x squared and add to 5x. So each of them is going to have an x, and those two numbers that multiply then are going to be written in the middle here and replace the 5x, or splitting the 5x into two x terms. So those two numbers would be 8x and negative 3x. Then to factor, we're going to factor by grouping now. So we're going to look at the first two terms. What do they have in common for a GCF? They both have a 2x. So we're going to have 2x out front. Inside the parentheses then we'd be left with x plus 4. In the second two terms, we have negative 3 as the GCF. So we have x plus 4 equals 0. Now, why did I take out a negative 3 instead of a positive 3? I need these two parentheses to have the same signs and the same information inside them. So now that I have that, what's outside is going to go in one parenthesis together. So we would have 2x minus 3. And then we're going to write the repeating parenthesis once, so x plus 4 equals 0. Then when we solve, 2x minus 3 equals 0. So we have 2x equals 3, x equals 3 over 2. And x plus 4 equals 0, so x equals negative 4.